Alright, welcome to a lesson on operations with square roots. Before you learned how to simplify square roots, now we're going to work with adding, subtracting, multiplying, and dividing some square roots. So let's get started. So addition and subtraction. Over here on the left we have an example of how this is going to work, and we're using variables because we've been very familiar with variables throughout the year. 3x plus 4x. We know that we can add these because the x is the same, so 3x plus 4x, 7x. 5y minus 2y, again, y and a y, that works, 3y. Now we have 5x, 7y. Those aren't the same variable, which means that we cannot actually add them together, so simplified it's simply 5x plus 7y. That's as simple as we can make it. That same concept applies over to our square roots. We need to have square roots that are the same. Square root of 2, square root of 2. That's the same, so we can add the numbers in front. So 4 square root 2 plus 2 square root 2 is 6 square root 2. You do not add the numbers under the square root. You do not add the numbers under the square root. You just add all the numbers outside the square root. That's very important. That's something that you got to get used to because you'll make that mistake every now and then. But you only add the numbers outside the square root. 5 square root 5 minus 7 square root 5. Square root 5, square root 5. That works. 5 minus 7, negative 2, square root of 5. Then we have 3 square root 3 plus 2 square root 7. Square root of 3 and the square root of 7. Not the same. So we cannot add them together. So simplified, it's just 3 square root 3 plus 2 square root 7. Okay, I'm going to do the top two examples with you, then have you do the bottom two. And here we're going to actually start applying more what we did with simplifying square roots with our operations. So we have 2 square root 12 plus 3 square root 12. Hey, square root 12, they're the same, so we can add the numbers in front and we get 5 square root 12. But we are not done. We know that the square root of 12 can be simplified, so we need to simplify it. We need to simplify completely. So we simplify 12, circle our pair of 2's, so we get 10 square root of 3. So simplified, it's 10 square root 3. So that's one scenario that you'll see often, where you have two square roots that you can add together, but then you have to simplify. This next one you'll also see where you have two square roots that aren't the same, so we can't add them together right now. But we look, 7 square root 24. We know 7 square root 24 is definitely not simplified. Square root 6 is, but that square root of 24 isn't. So what we need to do is we need to simplify that square root of 24, see what it gives us, and then see if we can actually add them. So 24 breaks down into 6, 4, 2 and 2, 3 and 2. We got a pair of 2's. So looks like this simplifies into 14 square root of 6. And then our minus 3 square root 6 follows. Now we can square root 6, square root 6. Hey, we can add the numbers in front now. So 14 minus 3, 11 square root 6. Okay, so there's two examples. There's two more down here that you need to do on your own, so go ahead and pause the video now and work those out. Alright, and here are the answers to those two examples. You will note on the second example that we got a 4 square root 5 minus 4 square root 5, and that makes 0, so the final answer was just 3 square root 3, just if you were curious about that. And let's move on to multiplication. I find multiplication is actually easier than addition, subtraction, and it's definitely a bit easier than division. When we multiply, we don't care what the square root is, how big it is, how small it is, if it's the same, if they're different, we just get to multiply. And when you multiply the outside, then you multiply what's on the inside. So, we start with the outside. 3 times 2, that gives us 6. Multiply the inside, 3 times 6, that gives us 18. And then again we check, is that square root simplified? And we know that 18 is not. So we have to simplify that 6 square root 18. That breaks down into, well, we just multiplied 3 and 6, so 3 and 6, 3 and 2. Here's our pair. So pull out one of those 3's, and we get 18 square root of 2 as our answer. Next we have 4 square root 8 times 3 square root 6. Again, who cares what they are, outside or inside, we just get to multiply. 4 times 3, 12, 8 times 6, 48. Now we need to simplify that square root of 48. So 12 and 6, 2 and 6, and hey look, we get a pair of 6's with a 2 left over. So 12 times 6 is 72, square root of 2. Now we add in some variables. Works exactly the same as when we multiply variables before. So we have the square root of 2x times 3 square root 10. Now if there's not a number in front of the square root, we assume there's a 1, just like with variables. So 1 times 3, 3. Then we need to multiply the numbers together. 2 times 10 is 20. X times x, x squared. And we have to do a little bit of simplifying. So 20 breaks down into 2 and 10, 2 and 5. So we get a pair of 2's. X squared, that's x times x, so there's 2 x's. So both those x's get to come out. So we get 3, sorry, not 3. We do 3 times 2, which is 6, x square root of 5. So there we go, there's our answer. And finally we get the distributive property. And this distributive property works the same as any of the others. We're going to multiply this 3 square root 2 to the 4 to the square root of 6. We're just going to use our new ideas with it. So 3 square root 2 times 4. Well, 4 doesn't have a square root, so we just get to multiply the outsides. So 3 times 4 is 12. Square root of 2 follows. That square root of 6 has a 1 in front of it. So 3 times 1 is a positive 3. The square root of 2 times the square root of 6 is the square root of 12. We need to simplify the square root of 12. 4 and 3. 2 and 2. And we get 12 square root 2 plus 6 square root 3. We can't simplify that any further because the square roots are different, and this is addition now. So, there's 4 examples. Now here's 4 examples for you to try on your own. So go ahead and pause the video and try these examples now. Alright, and here are the solutions to those example problems, so go ahead and check your work now. Then after you do that, we're going to now talk about division. And division is a little bit different. To put it plainly, You cannot have a square root in the denominator of a fraction. It can be in the numerator, but cannot be in the denominator. So basically, whenever we're dividing by these square roots, we're basically getting them away from the denominator. So 5 over square root 3. The issue is that square root 3 in the denominator of the fraction. So we need to get rid of it. Well, we know that in order to get rid of something with division, we're going to need to do some multiplication. So what we're going to do is we're going to multiply by another fraction. The fraction we're going to multiply by is our problem and our problem. Now our problem here is the square root of 3. So we're going to multiply this by the square root of 3 over the square root of 3. If you were to type the square root of 3 divided by the square root of 3 in a calculator, what you're actually going to get is 1. So what we're actually doing is we're not changing what this is, we're just changing the way it looks. So when we multiply, we now get 5 times the square root of 3 is 5 square root 3 over square root 3 times square root 3 is the square root of 9. Well, the nice thing about the square root of 9 is it simplifies to 3. So we have 5 square root 3 over 3. That's our answer. On the right here we have 4 square root 10 over 3 square root 6. Now if there's numbers on the outside of both your square roots, first check and see, hey, can I simplify those? 4 and 3 won't work. Next, look at the numbers on the inside of your square root. If you have 2 square roots, one in the numerator, one in the denominator, you can do this. We can break this up into 2 separate fractions. We can break it up into 4 divided by 3 times the square root of 10 over 6. Actually, let's not do that. There's another way we can do that, and I'd rather do it this way. So, apologize for that. So, we can't simplify the 4 and the 3. Let's look. If they're underneath the square root, if they're both under a square root, we can simplify them while they're there. 10 and 6. What can we divide both 10 and 6 by? 2. So we can divide both of these by 2. And this becomes 4 square root of 5 over 3 square root of 3. Now, what that does is it simplifies our problem in the future. Instead of multiplying by square root of 6, we're going to multiply by square root of 3. Because again, we have a square root of 3 that's in the bottom, and that square root of 3 is our problem. So we multiply by square root of 3 over square root of 3. Now you're probably wondering, why don't we multiply by this 3 on the outside? Well, that 3 on the outside isn't an issue. You can have a 3 in the denominator of a fraction and it's fine. So, we're going to use our multiplication rules. And on top we get 4 square root of 15 over 3 square root of 9. That square root of 9 turns into a 3. So we get 4 square root of 15 over 3 times 3. This 3 coming from that square root of 9. So we get 4 square root 15 over 9. Now we need to be careful here. This 9 and this square root of 15 cannot be simplified. Just like over here, I did simplify this 3 and this 3. The reason being, one's under a square root, one is not. You cannot mix those together. So 4 square root 15 over 9. One more example, this one's just a little bit more complicated. 6 square root 8 x to the third over 4 square root 6x. Look at the outside numbers. We can simplify this 6 and the 4. They break down into a 3 and a 2. We look under our square root, we can simplify as well. We can divide both 8 and 6 by 2, and we get 4 and 3. We look here with our x's. I have x to the third and x. if I have 1x on the bottom and 3 on the top, I can take away this, and I can take away 1 from here, making that an x squared. So this now becomes 3 square root of 4x squared over 2 square root 3. And again, it looks like our problem is a square root of 3. So we're going to multiply by the problem over the problem. We get 3 square root of 12x squared over 2 square root of 9, and now it just becomes a simplification game. So we need to simplify this 3 square root 12 x squared, 4 and 3. So this becomes 6 x times x, x. So the top becomes 6x square root 3 over, that square root of 9 turns into a 3, so we get 2 times 3 in the denominator, and we get 6. Now we look again. Hey, this 6 and this 6 cancel, so we get x square root 3. So I know that one seemed a little complicated, but that's just because there was a lot of simplifying, a lot of little steps. So it wasn't really hard, there were just a little tiny steps that we had to take to get there. Alright, so here are 2 examples for you to do, so go ahead and pause the video now. And here are the answers to those examples. The left one was kind of a trick, I just wanted to see if you could figure it out or not. So the right one was pretty straightforward, so after you've checked these over, you're done with this video.